Hi, Honors Algebra 1. It is Wednesday, May 13th, and you just finished your last test yesterday on Chapter 12, so congratulations. We are going to spend 2 days working on trigonometry. And you might say, Mrs. Gill, really? We just finished Chapter 12. I said, really? Because we're going to spend a lot of time in trig next year, and it's really important for us to just get a introduction to it, to see what it's about. So next year we're going to dive in and do 2 big chapters on it, and it's 2 of the more difficult chapters. And so students are really, really appreciative if they have just a general knowledge, a general introduction, understanding of what trigonometry is. So we're going to do 2 days learning about it. And then actually on Thursday, I'm going to give you just a short 10-question quiz to take and turn in next Monday morning with your assignments. The assignments are going to be short. I'm going to give you just a few problems in the textbook. And then you're also going to have added to that a few problems in Khan Academy. If for some reason you've forgotten your password or your username for Khan, please go ahead and just message me. I have your username, and I can change your password so you can get in there. I just found that out. So, excuse me. So let's go ahead and talk about trigonometry. Well, what is it, first of all? It's the study of the measurement of triangles, the study of the measurement of triangles. All right, so to start out, we're going to just be talking about right triangles. We know that the Pythagorean Theorem only works with right triangles, and our basic trig ratios also only work with right triangles. So let's review here our 3 sides of a right triangle. We have 2 legs, and the legs are the 2 sides of the right angle. That's very important. The legs are the 2 sides of the right angle, and then the hypotenuse is always the longest side of the triangle opposite the 90-degree angle. Opposite means across from. Now, we can also define our legs to be opposite or adjacent legs to a specific angle. Now, let's look down here at this triangle, and I have labeled angle A over here, and I put a little arc right there to designate angle A. Well, the hypotenuse is always the hypotenuse. It's never going to change. But we're going to have to understand which of the 2 legs for angle A is the adjacent leg and which is the opposite. Okay, if I sit opposite you at the dining room table, I'm sitting across from you. So the opposite leg is going to be the leg across from angle A. So let's look at angle A and go straight across. Here is the opposite leg to angle A. Now, if I'm sitting adjacent to you at the table, I'm sitting right beside you, And so for angle A, this leg right here that is not the hypotenuse, it's the leg that's part of angle A. It's right next to angle A. It's right next to it is the adjacent leg. Okay, the adjacent leg is going to be one of the sides of the angle, okay, and the opposite is going to be across from it. Now, let's go ahead and label this angle up here angle B and figure out which are my adjacent and opposite legs. So for angle B, let's first go straight across. This leg is the opposite leg for angle B. And the adjacent leg is going to be this leg right here. It's right next to angle B. It's adjacent. It's right next to it. Okay? So for angle B, the hypotenuse represents one of the segments, and the adjacent leg represents the other segment that make up angle B. Opposite is across. Okay, that's very important. That's really the key. That's the key to understanding how these work. Now, trig ratios, what are those? Now I call them trigonometry. Trig is just short for trigonometry. They are the ratios of the lengths of the sides of my right angle. So I see I'm in the zone. Let's do this. Okay, there we go. Okay, now there's 3 trig ratios that we're going to learn this year. Next year we'll bump it up to 6. But for this year, we'll start with 3, the basic 3. And these are actually the 3 that are on your calculator. We'll learn tomorrow how to use them. But if you look here, you've got sine, cosine, and tangent on your calculator. Sine, cosine, and tangent. Now, the sine of angle A, sine is abbreviated SIN, but don't say the sin of A, okay? Say the sine. The sine of angle A. Now, you can have the sine of angle B, Z, Q, P, whatever. But let's just choose A. So I wanted the sine of angle A. I write it as sine A. That means that little sin, it's not sin, it's sine, okay? Now, what is that ratio? Well, it's the ratio of the length of the opposite leg to the length of the hypotenuse of that particular triangle. What is the cosine of angle A? Well, we call that COS. Okay, first 3 letters, just like sine. The cosine of angle A, you just put cosine of A. And you always put the angle after your ratio. Cosine of A, sine of A. All right, what is the cosine going to be? It's going to be the ratio of the adjacent leg's length over the length of the hypotenuse of an angle. And finally, the tangent of angle A, we call that tan, like the color tan. The tangent of angle A is the ratio of the opposite leg divided by the adjacent leg. Okay, now, how can I remember that? Well, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, a lot of books will go ahead and use this little acronym. It's SOHCAHTOA. SOHCAHTOA. Sounds a little bit Asian, doesn't it? SOHCAHTOA. Okay, now, what is it? Well, so is, this is sine, S stands for sine, and the next 2 letters, OH, are opposite over hypotenuse. So the sine is the ratio of the opposite leg divided by the hypotenuse. Ka. The cosine next is the ratio of the adjacent leg length divided by the length of the hypotenuse. And then TOA, TOA, T-O-A. The tangent is the opposite leg length over the adjacent leg length. Okay, well, let's go ahead and put these into action. All righty. Now, I have got a triangle right here. Can you see it? I'm trying to get it where I don't have the reflection. Okay. I want to find the sine, cosine, and tangent of angle B, Now, we have to be careful. We're not finding the sine, cosine, and tangent of angle A or C. All right? Just angle B. So I'm going to go ahead and actually mark B with a little angle mark there. Okay, angle B. What is the sine of angle B? Sine. So it is the opposite leg length over the hypotenuse. So let's look at our figure here. Angle B, what is the opposite length? Go across here to a leg. Remember, I've got a leg of 15, a leg of 8, and a hypotenuse of 17. So let's see. 15 is defined to be the opposite leg, and its length is 15. Well, obviously it's 15, okay. And then, what is the next thing? Opposite over hypotenuse. Well, the hypotenuse is 17. So the sine of angle B is 15/17. That's it. It's just the ratio, okay? It's a fraction. Let's go to the cosine of angle B. The cosine of angle B, is going to be the adjacent leg over the hypotenuse. Well, angle B, what's my adjacent leg? It's the leg right next to angle B. It is 8, and we know the hypotenuse is 17. So 8/17 is the cosine. And then what is the tangent of B? It's going to be TOA. It's going to be the opposite leg length over the adjacent. And so, what do we have here? The tangent of B is going to be the opposite 15 over the adjacent 8. And there is the tangent of angle B. Now, let's switch it up a little bit. Let me go ahead and, I was going to get a red here. Let's see. Let's go ahead and find the sine of angle A. Let's find the sine of angle A. So let me mark angle A right there with the red marker. Okay. Now, the sine of angle A. Well, it's going to be different from the sine of angle B because we're actually going to be switching the legs, okay? The adjacent leg will be 15 and the opposite leg will be 8. So let's start with the sine. So, opposite over hypotenuse. Opposite 8 over hypotenuse 17. Okay, see how it's different from the sine of angle B. Let's go to the cosine of angle A. That's going to be ca, my adjacent leg length over my hypotenuse length. Well, for angle A, the adjacent leg is 15. Remember, 17 is always the hypotenuse. It's never a leg. So just ignore 17 when you're trying to figure out opposite and adjacent. So I have cosine of A is going to be my adjacent 15 over my hypotenuse 17. Sorry, I made that kind of small. Now, what is the tangent of angle A? B, okay? Tangent is opposite over adjacent, TOA. So, the tangent of angle A is going to be my opposite over my adjacent. It's going to be 8 over 15. Okay. Let's try one more. I hope this is sinking in. All right. Let me move this around again. And let's flip to the other side and do one more triangle. Okay. Here we go. We want to find, now these are not A, B, and C angles. These are P, R, and Q. P, R, and Q. Now, we want to find the sine, cosine, and tangent of angle Q. Angle Q. So let me mark angle Q so it stands out. And it's that red angle right there. Okay. Now, what do you notice about this one? We are missing a side leg. And are we missing a leg or the hypotenuse? We are missing one of the sides of the right angle, which is going to be a leg. So what have we learned we can use to find a missing side length of a right triangle? Yes, the Pythagorean Theorem. So let's go ahead and solve that. I'm going to go ahead and take my leg, 6 squared. Now they defined, this is a problem from the book, they just defined this side to be A, you know, because A squared plus B squared equals C squared. You can call it anything you want to call it. It's fine with me, but they called it A. All right. So I've got 6 squared plus A squared equals 14 squared. Leg squared plus unknown leg squared equals hypotenuse squared. All right. Now notice that this triangle is all flipped around. Don't worry about that. Your legs, just look for the right. Let's look for the little right triangle. Right angle symbol, and you'll know exactly where your legs are. 6 and A. Okay. Now I've got 36 plus A squared equals 196. A squared equals 160. A. Okay, now I rushed this. I shouldn't have done that. A is going to be the square root of 160, okay? And I'm going to write that as 16 times 10. Excuse me, A. Now, normally it's plus minus, right? Plus minus. That was from the last chapter. But it's a side length, so we ignore the negative. And so A, let's simplify that, is 4 root 10. Okay. So A is equal to 4 root 10. 4 root 10. I'm going to go ahead and even erase that A right there. Boom. 4 root 10. Okay. Now, let's start by finding the sine of Q. All right. Let's go ahead and remember our little SOHCAHTOA. Sine is opposite over adjacent. So, and so my opposite to Q, what is my opposite leg? Okay. Is it 4 root 10 or is it 6? Of course, it's opposite, it's cross, it's 6, and the hypotenuse is 14. So I've got 6 over 14, and that should always reduce these, always reduce them. This reduces to 3/7. Okay, let's go to, everyone okay with that? I hope so. Now let's go to the cosine of Q. Well, the cosine of Q, let's put that, ca, adjacent leg over hypotenuse. Well, what's the adjacent leg? The adjacent leg is 4 root 10. So I've got 4 root 10 over the hypotenuse. Now, can that be simplified? You betcha. 4/14 is 2/7, so I've got 2 root 10 over 7. Finally, let's go to the tangent. Let me try to move this. Oh, my word. Okay, here we go. Let's go to the, oh, now you can't see the triangle. All right, well, let's just put it right here. The tangent of Q is going to equal what? TOA. All right, it's going to be the opposite over the adjacent. 6 over 4 root 10. All right, let's write that and see if we need to simplify. 6 over 4 root 10. Well, let's first go ahead and reduce 6 over 4 to 3 over 2. Now, what did we learn in, I don't know if this is I think it's the chapter before this one. Can I have a radical in the denominator? No. So I've got to rationalize the denominator. Got to make it a rational number. So remember how to do that? I'm going to multiply numerator and denominator by root 10. So let's go ahead and do that. I'm going to have root 10 over root 10. And let's see what we get here. I'm going to have 3 root 10 over 2 times the root of 100, or the square root of 10 squared is 10. So this is 2 times 10 is 20. So my tangent of angle Q, the opposite over the adjacent, is 3 root 10 over 20. That is the most basic of trigonometry concepts. Sine, cosine, and tangent. Okay, go ahead and try it. Try it. You've got a few problems in the book. You've got a few Khan Academy problems, and then tomorrow we will take this information and actually use it to find missing side lengths in triangles. Missing side lengths in triangles, okay? And with the Pythagorean Theorem, you need 2 side lengths to find the third. With trigonometry, if you have an angle and you have a side length, you can find other side lengths, which is really, really cool and helpful. Okay. All right. Well, I will see you tomorrow. Come see me at Zoom at 11 if you would like some help with this introduction to trig. Have a great Wednesday. Bye-bye.